Hi, I'm Kyle Houchins. I'm a tech and a trainer for McNeil, and this is Getting Started Rhino for Windows. We're going to do something a little bit different today. And the idea, instead of doing the typical kind of uh, me put up a picture and build the model and talk about the build and all that kind of stuff, we're going to actually look at how to deal with something that you need to print, that you need to get to a printer. And this is a piece that actually came across my desk from a friend and artist named Zachary Oxman. You can look up his stuff at zacharyoxman.com and take a look at the kind of stuff that he does. And for instance, he did a piece like this that's installed in an office building that's about 50 feet long. This is not that big. In fact, let's figure out how big it is. And I'm just going to throw a dimension on here. And this thing is about 30 inches, and we can verify that. Anytime somebody gives you a file, make sure that you go through the process of figuring out, is it inches? Is it millimeters? Is it feet? Is it, what is it? In this case, it's inches. Our tolerance is 0.001, which is fine. And we know that this dimension now is 30 inches. So this piece isn't huge. Now, he has done pieces where this would be, 35 or 40 feet. But in this case, this is kind of more of a desktop piece. And he called me this week, or actually last week, to talk about how to manage this because he wants to break this up for printing. And he's going to actually send this to a wax printer, get it broken up into pieces, and then cast it. And then he's going to weld it together and do some stuff with it, do his thing. So what he originally asked me to how to do was, how do I shell this thing, right? And it seems like a really easy thing to do. But the problem is when you're dealing with meshes, you get very often what's called a bow tie. And when you offset a mesh inside, if the offset is bigger than the thickness of the part, you get a bow tie. And the way to explain that is if I have a corner like this, and I were to offset this piece to here, and I were to offset this piece to here, these pieces cross and create what's called a bow tie. And this is a less than ideal situation if we're looking at this, and this would be a section. Imagine if I just cut a section through here and then offset it, you would get this bow tie. And what happens is this makes a mess for printers because what happens is the normal is facing this way here. It's facing this way here. And it's facing this way here. And so for the mesh, it doesn't know, is this the outside or is this the outside or is this the inside or what is this? So it gets confused and it makes a problem. So this is a no good situation. We don't want that. And what often happens when you offset a mesh is you get this bow tie situation, which makes the inner part of the mesh essentially either useless or not very useful, things like that. There's another aspect of Rhino that we need to talk about. And if I look at this up here, and by the way, for those of you who have just joined, these are considered to be interactive, so please feel free to type questions in the chat, and I'll be more than happy to answer. If you see something and you're like, "What in the world is he talking about?" Let me know, and we'll try to explain it a little differently. So the other issue with shelling things is if I were to try to shell this cube, and let me hide this for a second, and I were to try and cut the center of it out, right? Like if I tried to do this, Rhino doesn't know that these two things relate. This is essentially just a Russian doll of a box inside of a box, and it doesn't mean anything. It's not connected in any meaningful way. It's just hanging out in space. And the problem with that is I can't Boolean it. So if I try to Boolean subtract this from this, it says objects don't intersect, nothing done. So what we have to do actually to shell something like this in Rhino is we either have to use the shell command and we have to pull out a face so that it actually makes like a, you know, a box with an open lid, or we have to connect the inside and the outside by doing something like this, where now I can remove this from this because they now connect, and I have to leave myself some sort of passage so that the normal faces out here, it faces inside, you know, pointing to the inside in this tube, and then it goes inside and then it points inside there. So it knows what the direction of that is, and I can show that. If I show the normals here, you can see the normals travel on the outside here, they travel on the inside here, and then they travel on the inside there. So it understands what this volume is. Okay, so knowing that, this is a very key piece of the puzzle when we're talking about Booleans here, because we have to understand this connection between the two. So now if I look at, say for instance, this piece, right? And the goal here is I need to break this thing up into pieces because it's too big and too thick, and I don't want to print this much wax, and I don't want to print, and I don't want to cast this much stuff because the you know, the metal will sink and it's expensive and all that kind of stuff, right? So we want to break this thing up into pieces. And so what we're going to do is I'm going to make some cuts, and I'm going to make the cuts based on these splits here. And in V7, if you've tried to do any mesh work before in V6 or V5, and you were, shall we say, underwhelmed, come back to 7 and give it a shot in 7. We've improved the mesh intersector quite a bit, and this is a much less horrific process than it was previously. So what I'm going to do is I'm going to pop out the mesh tools here, and there's a set of mesh booleans down here, which a lot of people don't know about, right? There's the NURBS booleans up here, but there's also a set of mesh booleans that live in here, and we're going to use the mesh booleans on this because obviously we're working on a mesh part, right? So what we're going to do is I'm going to take this and I'm going to split this object. Actually, not going to do that yet. I'm going to, let me hide the splits. The first thing I'm going to do is I'm going to offset this entire mesh part. And we're going to do that with mesh offset. And I'm going to mesh this to 0.25, and I'm going to let it run. And what it's going to do is it's going to create my offset on the inside. And you say, well, gee, that was easy. It also joins the mesh into one piece. So what we actually need to do is explode this, and then we need to hide the outer and hide these little pieces here in order to be able to see the result. And if I shade this, you can see that we get some really thin spots. We get some stuff up in here that's kind of ugly, and we get this type of situation, which is the self-intersection that I was talking about, right? This side offset over here and this side offset over here, and these parts over here crossed, and that's not ideal. However, in this particular case, what we can do, because we can separate the inner and the outer just with explode, we can take this and we can split it up and then use this. We can split the outer, and then we can use this to core out the center. So bear with me. This is a little bit of a mental puzzle in order to try and like get through the steps here. But what we're going to do is we're going to take the outside, and I'm going to hide everything, right? And so we're going to end up with this. And actually, I'm going to bring my cap back down here because I want this cap to be joined back to the outer. So now I've got my one closed mesh. I'm going to isolate that using the isolate command. I've got a hotkey set up for that. And that makes this the only piece that's available in the scene, right? So I'm going to bring my splits back, and these are mesh panels. I just made these with a simple surface, and then I meshed the surface in order to be able to get these mesh pieces. And the reason that I did that, and I'll show you the difference between if I split something with a mesh versus if I split something with a surface, which you can do. You can split things with a surface. It's not a problem. But if I make a surface and I split this, let's look at the result. Now, the only way that I can split this with the surface is if I use the mesh booleans, which live down here, right? I can't do that with the NURBS booleans because it won't accept a mesh input. But if I pull this off, you can see what happens. See how ugly this split is? See the polygons down here and how disgusting those are? These long stretched out polygons are going to cause you all sorts of problems. If you see this in your model, we have to either QuadRemesh or rebuild the mesh or something, because this is not ideal. So let's get rid of that and then look at what happens if we do the same type of split, but we do it with a mesh result. And so I take this, I'm going to split it with this guy. You can see that it completes, but what it does is it actually takes the topology from this guy. So this is a much better situation because this amount of polygons, you know, the polygons are evenly distributed and all that kind of stuff, and you know, all that kind of stuff. So that's what we want to do. So what we're going to do is go through and we'll just go ahead and split this up with all of these other pieces. And like I said, this was an exercise in frustration if you tried to do this in version 5 or earlier. So we're going to go ahead and cut this up. It actually completes it, which is fantastic because that's not what it used to do in version 5 or 6. We'll bring back our original core, right? And then I'm going to show you what we've got. And we've got something like this. Now, the simplest thing that we can do is simply just Boolean that from this, and it works, and we get a really nice shelled part, and that's cool. And if that's all you need, then we can wipe our hands on our apron and call it done, right? But what we really want is we want to be able to use these pieces and this. We want to create little keyways so that when these attach, we know exactly how they're going to attach, right? So what we're going to need to do is we're going to need to split the inner back a little bit so that we've got our 1/4 inch offset so that it's equal all the way around there. But then we're going to have this, scenario, right, with a cube inside a cube where the two pieces don't touch. I'm going to mute for a second. I've got to clear my voice. All right, and then what we're going to do is create a little keyway, which is going to be our tube that is going to cut through this, but we want that to actually have a little shape. All right, so let's bring back our core and our object, and then let's grab our splits. And I'm going to isolate just those pieces. And so what I want to do, actually I'm going to hide this. What I want to do is I want to offset these a 1/4 inch so that I've got, you know, I've got this tucked inside. So this core will be tucked a 1/4 inch in all the way around. Okay, does that make sense? Everybody still with me? So let's go ahead and do that. And we're going to just do that with a mesh offset. And I'm not going to do all of them. I'll just do a couple so that we can kind of move it along. And we're going to do our 1/4 inch. Oops, I want to do -0.25. There we go. And these, you know, anytime it connects like that, we just go ahead and explode and then join the two pieces up. So let's make a keyway for this guy right here. So what we're going to do is we're going to Boolean split this with our new offset piece, and we can get rid of that piece there, right? So we can hide these. And if we bring back the exterior, we will have this, which is what we wanted, right? We've got our piece is cut back, it's cored out. We'll just assume that we're going to do the rest of them, but I'm just going to do a keyway on this one. So then what we need to do is we need to build the tube, right? Back on our mesh, we need to bring, or our cube, we need to build that. But we don't want that to be spherical because we don't want there to be any errors in how these two pieces are registered. So what we're going to do is isolate this piece. And we're going to build an object right on the end of this thing. And there's a little bit of like, how do we do that? Like, how do we build an object on the end of this thing? And what we can do is we can build a custom seaplane. So we're going to come up here and we're going to do a 3-point plane. And I'm going to just stick the origin over here. And then I'm going to take and do something here. And then my third point, I'm going to set it to, I don't know, something like that. And we're going to build a custom seaplane that is oriented to the end of that thing. And I can move the seaplane. I can set the origin of this by just moving it. I'm going to just vaguely aim for the center there. So now what I can do is I can create a circle at 0, and let's just do something like that. I can pick the circle and then I can extrude it, and that gives me a little keyway, right? And I'm going to cap this, and then I'm going to be clever and I'm going to add a little dingle on the end of it here, for lack of a better term, that just allows me to be able to register this. And I'm going to cap, and I'm going to Boolean these two together with the NURBS Boolean because those are NURBS parts. And then I'm going to merge all coplanar faces, and that is going to clean up the end there. So I made my little key, right? Now, because I'm dealing with meshes, I have to mesh this thing. So I'm going to mesh it, and I'm going to preview it, and that's okay, pretty good. And I always use, for what it's worth, there's a simple mesh setup and a detailed mesh setup. If I click the detailed mesh setup, it brings this up. The only ones you need to worry about are from here down. So minimum edge length, these down. So the minimum edge length, this just sets what is the tiniest polygon that can happen in this mesh. Okay, and that's set to 4 digits past the decimal. The maximum edge length is how big can these be. So if I set this to 0.25 and preview, it's going to make a different mesh than it would before. If I set this to 0.1, you can see that it makes it smaller. And if I set to 0.01, it's going to make a much denser mesh because it can only allow those polygons to be 0.01. So 0.01 is probably overkill. So I'm going to go like 0.05. And that's going to give us, you know, a fairly balanced, fairly decent mesh. Now, maximum distance edge to surface, this should just be file tolerance, and we're at 0.001. So I'm going to just set that there, and it's going to say the mesh cannot vary from the basic surface more than that unit. And then grid quads, this is just how many quads it breaks up into before it starts triangulating. And I'm going to just set that to about 200. And that gives us a fairly decent balanced mesh. So I'm going to just delete the NURBS piece now. And I've got this and this, right? Now, what I want to do is I'm going to actually copy this and stick it on the clipboard. And then I'm going to Boolean these two pieces together. And if I was going to be really picky about this, I would actually build 2 pieces with a little bit of interference between the two, or a little bit of clearance between the two. So I would actually offset them just slightly, but I'm not going to get that nutty here. I'm going to just, we'll assume that you understand that, basically, like either scale this up or scale it down or offset it, or do it. You know, your original curves, you're going to make 2 objects where one's bigger than the other so that you've got some room when you print it. All right, but I'm not going to get too crazy about that. So let's Boolean these guys together. And so that gives us this piece. Now I'm going to paste my copy, bring everything back, and I'm going to grab my inner object, isolate, and I've got my keyway in there. Now I'm going to Boolean this together, which seems a little counterintuitive. You're like, well, wait a minute, we just Boolean the other side, so we've got two outies pointing at each other. But in reality, this is a cutter for this. So then what I'm going to do is if I Boolean subtract this from this, it gets and cuts the whole thing, shells it out nicely, but gives us this nice keyway, which then fits with this piece. And we know that those two things are going to go get it. Obviously, we would want to build some clearance in here and all that kind of stuff, but the process is the same. All right, so this is what we would do for the rest of the part in order to make this work. And in this case, with the rest of this, these pieces are thin enough that they're actually okay. And the way that Zach set this up originally, if you look at how he set this up, and let's go to a shaded view so you can see it. He actually built little keyways into his splits. And so when these things get printed, he built little indexes in here so he knows how they're going to, because he's going to weld this together and then hand finish it. So so we don't need to go this crazy for all of these pieces, but I just wanted to show the process and how you would do that in order to be able to make that work. So now we've got a shelled part that is ready to go. And the last thing that we want to do is we want to run a few checks. And what we're going to do is we're going to do cell open mesh, which is this command here. And ideally, we don't want anything to light up. If anything lights up, then that means we've got an open mesh that we have to sort out. We have to figure out what we need to do with it, which is typically filling or patching. So let's assume something got screwed up. So let's just, the simplest case, and we have a polygon that's missing. We run cell open mesh, and these parts light up. So I'm going to isolate those, and we're going to take a look at them. This one I don't need, I'm going to delete it. Actually, I do need that because I think that's the cap for the end of this thing. That's the cap for the inner. Okay, so I am going to keep that. I do the dumb things so you don't have to. But this piece lit up, and so I know the cutters, obviously those are open. I'm just going to hide those. But this piece is not supposed to be open, and it is. So I'm going to isolate, and then I'm going to use the show edges command, which lives down here. And this works for meshes and for NURBS objects. And when I run that, you can see that let's see, if I didn't know where it was, like say I was way out here, I can hit the zoom button and it's gonna bring me into where that is. And if there's more than one, it'll zoom to the first one, and then when you fix it, it'll zoom to the second one and things like that. So we've got a hole here, which means that we need to fix it. And in the mesh repair tools, there is a fill hole command. You click it and it's gone. And then we're gonna run cell open mesh again, and it doesn't light up. So we know we fixed it. Now, that was an easy one because it was on a corner, right? We are on a flat face, and we know how to fix that stuff. And if there was more than one, we would use fill mesh holes. It's a different command, and that would go through and find them all. But sometimes this is a command that doesn't have a whole lot of smarts or a whole lot of intelligence to it. So what happens if, like, say for instance, this were to make a hole something like this, and let's make it a little ugly. If we did that, right, let's say this is our hole, and I say fill mesh hole, let's spell it right, and I click on this and it automatically fills it, you can see that it does it, but it doesn't do an awesome job. And it actually kind of chewed up my corner, which I don't want. So then I have to use a tool called patch single face in order to make little bridges, in order to build bridges to things. Now I've got an edge here, right there, that I can play with. So let's go mesh, repair, edit, sorry, and we're going to patch. Where are you? Is it in repair? There we go. Patch single face. That was the right place to start with. And we're going to patch from here to here, and we're going to fill in that. So now this is coplanar with that, but I need to get over to here. So what I might do is I might go from here to here, and then I might go from here to here, and then I might go from here to here. Now this is not curvature by any chance. This is just planar, but it's doing a much better job than fill mesh holes did, where you can see I actually have most of my edge there. All right. Now, what do we do if we get a situation where we have to fix something? Let's say that it's something really kind of desperately bad. Like, let's say it's something like this, and this is not a terribly uncommon scenario to fix. Now, patch single face and fill mesh holes and all that kind of stuff is gonna really make kind of a hash of this, right? So what I'm actually gonna do is I am going to project a couple of curves onto this, and I'm gonna build a couple of proxy surfaces that I can then use as blend objects to put this back together. So if I take these and I project them onto the mesh, I will get this, right? And the thing to understand about these, anytime you project a curve onto a mesh, you get a bunch of little teeny tiny straight segments that are joined end to end. You can see, I don't know if you can see the faceting, but there's a bunch of little pieces end to end. That's not awesome for building stuff. So what we're gonna do is we're actually gonna rebuild these, and we're gonna use something pretty close. You can see that we're 0.0009 units, or 3.0009. And so I'm just gonna say okay, and then we're gonna loft those guys together, and we're gonna create a surface. Let's see, those are a little twisted, so let's see if we can fix that. I'm gonna pull that down to there, that down to there. That makes a little better surface. And if I refit it, it gets a little better. And we're going to say, okay. So that gives us that piece. Going to do the same thing here, rebuild. Say okay, loft. That one looks like it's in pretty good shape. Actually, I may pull that. Pull this down a little bit. Oops, not that. There we go. In that case, not simplifying made it better. Say okay. Now if I build a blend surface between these two, make sure they're going in the same direction, and they're not. So I'm gonna flip this. Actually, let's kind of bring it up here, something like that. I'm gonna flip it so the arrows are going in the right direction. See that? Arrow, arrow. Say blend, and then I'm gonna pull this into shape. May add a few more shapes here. Oops, went the wrong way. There we go. And let's use the Alt key to straighten this out just a little bit. And I'm going to just go tangency. I'm going to just play with the handles a little bit until we get a little better version of that. That looks okay. something like that. And we've got our essentially sleeve that we can use to repair this. Now, what we'll want to do is we're going to compare this and say, okay, well, like how close is it? And it's okay. It's not amazing. So let's see if we can use cell U, which selects everything in the U direction. And let's just scale this a little bit. See how it's getting closer? And we may even rebuild this. And instead of doing 3 and 4, we may do, well, so we've got 36 to start with and 4 in this direction. So let's do 6 in this direction. And that's going to give us a couple more rows of points. And then what we can do is cell U to select everything in the U direction, scale this just a little bit. Maybe we scale it in this direction. And we're going to just get our patch so that it's about where we would want it to be. Then what we'll do is we're going to mesh this piece and we'll delete the NURBS version of it. So now we've got a mesh piece here and a mesh piece here. So now what I want to do is I actually want to split this, and I'm going to leave a little gap, which seems counterintuitive, but stay with me. And let's extrude these. Whee! Mesh them. And then delete the originals. And then what we're going to do is, I'm going to hide this for the time being. I'm actually going to trim. We'll see how trim works. Sometimes the mesh trim is a little bit of a train wreck, but actually let's split it. So we're going to split the mesh using these two pieces, and that actually worked well. So we're going to actually just delete the mess, and then we're going to bring this guy back. Now, could I have fussed this a little bit more and made it a little smoother and all that kind of stuff? Sure, but I got an hour, so work with me, people. So let's patch a single face, and what we're going to do is we're going to create a little bridge from one side to the other, and let's go from like there to there, and I'm going to do that a couple of times. Patch from there to there, there to there. And if I do this enough times where I make a little connection between these two, then fill mesh holes can do the rest. So then I can click on that hole, that one, and I can kind of weld this thing back together. Helps if I grab the right edge. Should still have a hole there. We do. Looks like it wants me to patch a few more places because it's having a hard time figuring it out. So let's do that. Patch. We'll go from there. Come on, you. Oh, come on. Mesh. Patch single face. There we go. From that edge to that edge. Like that. All right, that'll work. Then we'll fill mesh hole again. There we go. A lot of times it has to do with just, are you grabbing the right edge? So I'm going to go inside so there's nothing behind it. And it looks like we need to patch a few more faces. So I'm actually inside the mesh looking out. Now we can. There we go. So that's got all of that knitted up. And I'm going to unify the mesh normals to make sure everything is going in the right direction. And then we would do the same thing down here in order to patch that up. So that's one way that you can use a NURB surface to go in and patch it. Now, is it beautiful? No. But in this particular case, because it's going to get printed and hand ground and hand welded and all sorts of stuff anyways, it's a lot better than having holes in the mesh. And you could print, you could loft more sections or be more careful or take more time in order to do your original blending in order to be able to get this section. But you could imagine if this was printed in bronze and you tap that with a grinder, which is what's going to happen anyways, then you'd be okay. It's a lot better than having big giant holes in your model, right? So that's another process that you can use to try and get this stuff put together. And we would simply do the same thing down here. We would just patch the single faces, make the little bridges, and then put that thing together. And then that would be a closed mesh part, and we'd be able to send that off to print. Now, when this thing is done, so let's say this piece is ready to go. We want to do a couple of checks, and I'm going to switch this to shaded mode. The first check we want to do is to show edges, which is this edge analysis. And we're going to add the objects, and it should say no naked edges, no non-manifold edges. And that's important, right? We don't want to have any open edges anywhere. The next thing that we're going to do is we're going to run the what command. And this is going to bring up a little report. And the things that we're looking for are valid mesh and closed polygon mesh. If these two conditions are met, chances are you are in really good shape to be able to print. The last one, just as overkill, I do sell open mesh. Nothing should light up. And if it doesn't, then you are in pretty good shape to do file, export selected. Oh, come now. I was like, don't you dare crash on me. I had my hard drive just spun up for a second. So export selected, and then we're going to do STL. It's already meshed, so we don't have to worry too much about it. Give it a branch part. I'm going to just throw this on my desktop. Say save. I'm going to send it out as binary, and I do not want to export open objects. ASCII is a text file. Binary is ones and zeros, so we're always going to send out binary. Say OK. Because the part's already meshed, it doesn't have to do the mesh, and we know that our part is then on our desktop, and we're ready to go. So that's one a way to handle this stuff. The other thing that we can do in this scenario here is, let's back up a little bit. Let me get rid of these things. Is we can utilize sub D to fix something like this. So let's take these two things and let's QuadRemesh them. And let's do something small. Let's do like, I don't know, 500. And we're going to say OK. And then we've got a QuadRemeshed version of this. If I run the to subd command, I'm going to take these from a QuadRemesh to a subd part. So now these are subd pieces. Now, because they're sub-D, we can start doing things like using like the bridge command, which is really fantastic. So if I grab this and I grab this and I bridge, and it says, let's see, edge loop, edge loop, and it says that it has to have matching number of edges. So I've got more edges here than I do over here, so that's why that's not working. So let's do it a little piece at a time. So we're gonna do, this is gonna be, I don't wanna do a loop. We're gonna do 1, 2, 3, 4, 5, 6. And then I'm gonna come over here and say 1, 2, 3, 4, 5, 6. And I can bridge those two together and I can decide how much straightness. Gotta add a couple more segments in here if we want it to smooth out. But we can blend between those using sub-D. We'll say okay, and we'll do that a few more times. We're gonna do 1, 2, 3. So 1, 2, don't want that one. 1, 2, 3, 4, 5, 6, 7. And we'll do the same thing over here. 1, 2, 3, 4, 4, 5, 6, 7. And we'll blend those two together. So we can start picking at this sub-D style, which gives us a little bit better version of what we had before. So now I can bridge 1, 2, 3, 4. 1, 2, 3, 4. I can bridge those together, and I've got 1, 2, 3, 4 here, and I've got 1 down there. So we got to figure out how to handle that. But in this case, I'm probably going to just let that roll, and I'm going to let it be fairly smooth. And then what we can do is stitch that. Grab these two. Stitch that. Got to make sure and grab the right ones. Let's go inside. Sometimes picking from the inside out is a lot easier. Stitch that. So that all comes together. So now we're just going to delete some edges in here and just let that be that way. And then we'll bridge from here to here with one segment. And that fills in. And then we can decide, like, you know, how many of these do we want to take out? Do we want to, you know, do we want to soften that, or what we want to do? So we'll go around and replace all of that, and then you simply come back and mesh this thing. That's a little big. That's even a little big. Changing the length, maximum edge length, and that you end up with your cleaned up part, and this actually gives you a much better repair. So with the tools that you have available, you can use sub-D, you can use QuadRemesh, you can use, you know, all these things, and that they kind of work together. You can use NURBS and then end up with a mesh result, which then gets you back to the point where if you bring this thing all back together, you can then, you know, finish it up the way that we had before, making your keyways and all that kind of stuff. And I didn't finish the end of this, but you get the idea of how that basically works, right? So the thing that I want to make sure everybody understands is QuadRemesh is kind of the secret key, the Rosetta Stone, so to speak, between NURBS, SUBD, and mesh. Because you can QuadRemesh a NURBS object, you can QuadRemesh a mesh object, and you can QuadRemesh a SUBD object. Now, once you're at QuadRemesh, you can go to SUBD. The command is actually to SUBD. It's just this. And it converts the QuadRemesh to a SUBD. Once you're in SUBD, you use to NURBS, which is just this, and it converts the SUBD to a NURBS object. So if you have a mesh and you want to end up with a NURBS result, QuadRemesh to SUBD to NURBS, and you've got a NURBS result. So that if we wanted to do this whole thing and have it be NURBS instead of mesh, we could do that. It's not, you know, the most painless process in the entire world. It's tedious and you have to, you know, kind of understand what you're doing. But the fact remains that adding QuadRemesh to the mix gives us the ability to be able to do stuff like this, right? Let's say this mesh offset was just a disaster, right? And there was no way to get this inside shell. What we could have done is QuadRemesh the entire branch, converted to SUBD. Well, check this out. There's an offset SUBD. Offset SUBD sometimes works better than offset mesh. The other thing about SUBD is if you QuadRemeshed it to a low polygon count and then went to SUBD so that the SUBD was manageable, you could just go untie that stuff. In fact, let's take a quick look at that and see. I'll show you. I think we've got a little bit, about 10 more minutes. So let's go back and take something like, let's do like this piece. And if we were to mesh offset this thing, and I'm going to break the end of this off because trying to offset a closed object always makes a disastrous mess. But let's take this and let's offset this mesh. And I'm going to offset it enough so that it bow ties on us a little bit. So you can see up here in the corner, got to explode it. So see this section right here, how that twisted in on itself? If I take this and I QuadRemesh it, and we do it something low, and we say like 500, and it might make a mess here, but that's all right. And I say, keep just this QuadRemesh. Now what I can do is I can figure out where this is, and I can untie it. So I could take, or I could even just get rid of it, right? So I could patch single face. The other thing I could do is I could take this now and go to SUBD, and I could take these edges, right, that are inside out, and I can scale them in the other direction and start untying this stuff. Or I could just say, you know what, forget it, delete all that stuff, bridge, got to have the same number of edges. So we got the same problem we had before, but that's, you know, we could do the bridge like we did before and just delete that part and get rid of it, right? So there's a lot of options as far as how to deal with this stuff. In fact, maybe we don't even need to take out all that much. Maybe we just need to take out this section, and we can straighten that out. Maybe it looks like this edge is turned inside out. So if I scale it, find out which direction it's inside out, looks like this way. We might even be able to take this side of it and just pull it back to the right side. So now I just untied that, right? And got rid of that little mess. And then I could stitch this back together with the other side or bridge it or do whatever I wanted to do. So there's a lot of options that QuadRemesh opens. It opens a door for you to be able to go a bunch of different directions to try and repair this stuff. So that's kind of what I wanted to show. And let's see, how many edges do we have here? 6 edges here. We've got 6 edges there. Those should actually bridge together. Let's see if we can do that. Let's just bridge. Yeah, so those will bridge together now that we straightened it out. And I'm going to put 2 segments in there, and then we can just dial that to where we want, join it back in. So now that's cleaned back up. Well, now that that's cleaned back up, let's say we want to add a little bit of puff here. We can just do that with scale on each edge. We can make these a little fatter to clean up that section. Then we would mesh. Then we would have our core set up so that if we brought this back, now I've got, nope. I've got this. So my core is now set up correctly. So now if I wanted, I could connect these 2 faces, or I could split it, or I could do whatever I wanted, right? Because now I've got my inside outside. I could patch from the inside to the outside and then do, you know, mesh. I could bring back my cutters. And I could use that to split the inside. Maybe I even cheat this a little bit. And I stretch it. And I just stretch from here to here, and I just pull this out a little bit. Then I can trim that off. That's make my new cuts. I got a bunch of stuff I don't need here anymore. Right? So I can split this. And explode this. And then I would need to trim the 2 of these apart, and then I'd be home, right? So that is kind of the dealio. So if I get this and join this up, that's a closed mesh. Let's see if it'll let me Boolean this out. No, it's got to be a little longer. So let's grab this one. I'm going to stretch this again. Just so it goes all the way out. So now I should be able to remove this. And there's my core with the part over here that's fixed. Now we didn't do the other side, wherever that was, but that would be the key. I may have actually grabbed the wrong part. I think I grabbed the part before we fixed it, but instead of the one that we fixed. But the idea is the same. All right. Any questions on that? I think that's about all I've got for you today. That's a lot. I know these are getting started, but they're and this one got a little deeper than typical, but I think it's good information to have out there. And if you've never used meshes before, then we'll call this getting started with meshes. But that's the general idea. Any questions for anything? Any questions on anything you saw? QuadRemesh, meshing, NURBS patching, projecting curves, anything like that? Just remember, anytime you project a curve onto a mesh, that you need to rebuild the curve, the resulting curve, because it's a bunch of single line segments joined together and it makes terrible surfaces. All right. All right. With that, I think I'll leave you. Thank you for joining. It's always funner to have an audience. And I will catch up with you next time. My name's Kyle Hutchins. I'm a tech and a trainer for McNeil. This is Getting Started Rhino for Windows. Go make great stuff. Thanks. Bye.